Hi everybody. So in this video, we're going to look at solving problems involving the binomial cumulative distribution. So we'll work through 4 exam style questions, and if you want to work along with me, you can download a copy of this PDF from my website. I'll leave a link below. So in our first question, we're told that 20% of light bulbs from a factory are defective, and 12 bulbs are selected at random. We're told to let U be the number of defective bulbs. Then we've been asked to work out each of these probabilities. So if we begin by defining our model, we'll say that U is distributed binomially with 12 trials and a probability of success of 0.2, which is this percentage here. For part A, find the probability of U being less than or equal to 5. So when we have less than or equal to, we can use the cumulative distribution on our calculators. If we go to Home, we'll choose Distribution. We want binomial CD, where CD is cumulative distribution. We'll choose Variable. Our X value will be this value of 5. We have 12 trials and a probability of success of 0.2. Then we can execute this, and we get the probability of 0.9806. Okay? And then for part B, find the probability of U being greater than or equal to 3. So even though we're looking at greater than or equal to, we can still use the cumulative distribution. If we look at the 12 trials, because we're looking at greater than or equal to 3, we're looking at these outcomes. But we know that through the 12 trials, we will get one of these outcomes. So together, they must all add up to make 1. So if we work out the probability of U being less than or equal to 2, so this will become 1 minus that probability. Okay? If we go back to our calculators, we can change our X value to 2. We'll keep N and P the same. And we get 1 minus 0.5583. When we work this out, we get 0.4417. Okay? So this is the probability of U being greater than or equal to 3. And then for question C, the probability of U being less than or equal to 7, but greater than or equal to 4. Again, if we look at the 12 trials, now we want all the outcomes that are less than or equal to 7, but greater than or equal to 4. So these outcomes here. So if we work out less than or equal to 7, which is all of these, and then take away less than or equal to 3, we'll get this probability. So this will be the probability of U being less than or equal to 7 minus the probability of U being less than or equal to 3. We go back to our calculators. I'll choose back. And again, now we'll choose binomial CD. And now we can choose list. We can enter in our U value as 7 and the U value as 3. So we can calculate both at the same time. We've got N and P the same. So then we get the probability of U being less than or equal to 7 minus the probability of it being less than or equal to 3. We can work this out and we get 0.2049. Okay? Let's try another question. So in this question, we're told that Amina plays an online game, and she assumes that each game is independent and knows from past experience. Now the probability of winning a game is 1/6. She plays 9 games. And then for part A, we're asked to work out the probability that she wins at least 3 of these games. So do you want to try this question yourself? Okay, so how did you get on with that? If we define our model as X being distributed binomially we've got 9 trials and our probability of success of 1/6. And we want the probability that she wins at least 3 of these games. So the probability that x is greater than or equal to 3. I should also define this random variable x. So I've said that x is the random variable, the number of games won. So to work out x being greater than or equal to 3, well, this will be the same as 1 minus the probability of x being less than or equal to 2. So we can work out this probability. We'll go back, binomial CD. This time we want variable. We'll enter x as 2, 9 trials, and a probability of 1 divided by 6. And we get 1 minus 0.8217, which is 0.1783. Okay, so this is a probability that she wins at least 3 other games. And then for the next part, we're told the probability of Amina winning a game is the same each day, and Amina plays 9 games on each of 5 different days. We need to work out the probability that she wins at least 3 games on exactly one of these days. So now we need to change our model. We've been given a new trial size of 5, and our probability of success will be that she wins at least 3 games, which is what we've just worked out here. So if we define our new model, we'll say that W is distributed binomially with a trial size of 5, and our probability of success now as 0.1783, where W is the number of days that Amina wins at least 3 games. And we want the probability of W equaling 1. So the probability of W equaling 1, if we go back to our calculators, we'll choose back, and again, binomial PD now, and the variable will be 1, number of trials is 5, and the probability of success is 0.1783. We can execute that, and we get 0.4064. Okay? Let's try another question. So in this question, we're told that Sarah is a basketball player, and she's practicing free throws, and she knows from previous experience that she has a probability of 0.3 of making a successful free throw, and she takes 8 practice shots. Using a binomial distribution, calculate the probability that she will make 3 or more successful shots. And then for part B, she takes 8 practice shots on 3 different occasions. Find the probability that she will make 3 or more successful shots on all 3 occasions. So if you want to try this question yourself, you can pause the video and come back when you're ready. So if we define our model, we'll say that x is distributed binomially with 8 trials given here, and a probability of success of 0.3, where x is the random variable, the number of successful shots. We want the probability that she will make 3 or more, so the probability that x will be greater than or equal to 3. And this will be 1 minus the probability of x being less than or equal to 2. So we can work this out. We'll have x is 2, the number of trials is 8, p is 0.3, and we get 1 minus 0.5518. So our solution will be 0.4482. Okay? And then for part B, we need a new model because now we've got a different number of trials, which is 3. So we'll say W is distributed binomially with 3 trials, and the probability that she will make 3 or more successful shots we've just worked out here. So P will be 0.4482. And then we're told we want the probability that she will make 3 or more successful shots on all 3 occasions. So the probability of W equaling 3. And this will be 0.4482, 3 consecutive times. So we'll cube this, and we get 0.090. Okay, let's try one final question. So now we're told that at a bakery, the quality control team has found that 10% of loaves are misshapen, neither labelled as defects, and loaves are picked in batches of 12. The number of defective loaves in a batch is denoted by X. State an appropriate distribution to model X, and state any assumptions needed for the model to be valid. And then for part B, assume that the model is valid and calculate this probability. And then for part C, a random sample of 4 batches is selected. Find the probability that fewer than 3 batches contain at least one defective loaf. So if you want to try this question yourself, you can pause the video and come back when you're ready. Okay, so how did you get on with that? If we define X as being distributed binomially with 12 trials and a probability of success of 0.1, we don't need to define X because it's defined for us here. In order for this model to be valid, we need to assume that the loaves are picked independently, and that the probability of each loaf being selected remains constant. And then for part B, assuming that our model is valid, find the probability of X being greater than or equal to 3. Well, this will be 1 minus the probability of X being less than or equal to 2. So if we go back to binomial CD, we'll choose X is 2, N is 12, and P is 0.1. And this will give us 1 minus 0.8891, which we can work out as 0.111 to 3 dp. And then for question C, a random sample of 4 batches is selected. Find the probability that fewer than 3 batches contain at least one defective loaf. So we need to define our new model, where W is distributed binomially. We've got 4 trials, and we need a probability of at least one defective loaf. And this is the probability of X being greater than or equal to 1, which is the same as 1 minus the probability of X equaling 0. We can work out X equals 0 as 1 minus 0.2824. So for X being greater than or equal to 1, we'll get 0.7176. So this will be the probability in our model for W. And then we want W being fewer than 3 batches. So this will be the probability that W is less than 3, which is the same as the probability of W being less than or equal to 2, which we can work out as 0.3174. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson and a PDF that accompanies this video from my website, mrmathematics.com. I'll leave a link below.